you all here this afternoon. My name is Bill Corey. You can see on the screen there, it's bill.corey@pentair.com if you want to email me. Joni mentioned that earlier. I am part of the training team here. This afternoon, we're going to talk about basic drives. And when we say basic, we're really talking about residential, not the bigger agricultural drives where you've got to do a little more to them. These are real simple plug and play. They've got a lot of features and benefits with them too. So we'll see if we can hit on some of this and make it easy for you to understand what we're talking about. Okay? So the first thing we're going to do here is point out that you can always go to the pentairlearningcenter.com if you ever need to review one of the webinars that we've done. We've tried to record everything, so they're listed in there under previously recorded, and that way you'll be able to see what we've done in the past. So anytime you want to go there, just go ahead and sign up, get registered, and you go in and use it. All right? So we'll start out with the fact that we're going to talk about basic drives. And when we talk about basic drives, we're going to look at what we're offering. We're offering something called the PID, and I have to admit that's not my favorite name, mostly because of the fact that PID stands for something in drive language. And so when you call it PID and then say it's going to go in PID mode, it confuses some people. So I just want you to know there's two different meanings there. When we say PID as the name, it means Pentair IntelliDrive. All right? It is always 230-volt single phase in. So your input is always going to be 230-volt single phase in. Now, of course, you can get single phase out. It's one of the drives where you have the option of single phase or three phase out. So if you put 230-volt in, you can get 230-volt single phase out. If you're going to do that, it must be submersible motors only. This can be used for above ground or submersible pumps, but if you're going to use it as single phase output, it has to be submersible motors. They're made differently, and I know that there's 4 different parameters that you have between an above ground motor and a submersible motor. And when we first came out with the drive, it was originally designed and intended for submersible motors only. And so of course what wound up happening, some guy insisted, well, it's a drive, it's 3-phase. What difference does it make? 3-phase is a 3-phase motor is a 3-phase motor. He burned up 4 3-phase motors above ground before he realized there was a difference between submersibles and above ground. So just make sure that you understand that, okay? 60 hertz only when you're doing single phase output. You've heard a lot of the drive manufacturers, they make 80 hertz drives. When they're 80 hertz drive, what they're basically doing is they're taking a motor and then putting a liquid in on it that's half the size of the horsepower of the motor. So if it's a 1.5 horse motor, they put a 3/4 liquid end on there. And of course, what eventually winds up happening then is you can now take it up to 80 hertz, but you can only do that with 3-phase. Single phase power, the windings are made different. You don't have 3 of the same windings, and so the windings are different. And if you try to do 80 hertz, you'd wind up burning it up. Of course, the drive is made so that way you can't do that, okay? If you want to, you can do 3-wire operation because single phase is 3-wire or 2-wire. If you're going to do 3-wire operation, you can go up to 2 horsepower. All right? Anybody's motor. It doesn't matter whose motor it is. You can use any motor up to 2 horsepower. If you want to do 2-wire operation, of course, you're only going to go to 1.5 horse because that's all the higher 2-wire motors go to. But more importantly, it must be a PSC motor. PSC stands for permanent split capacitor. And the reason that we're making that designation is because Franklin doesn't use that. They use a split phase motor on their 2-wire, and because you're using a split phase motor, it doesn't work with this drive. So you have to use either our motor or the Gould's motor, which is also a permanent split capacitor. You can do three-phase out, and if you do, you can use it for submersibles or above grounds. So that's kind of nice, submersibles or above grounds. Up to 5 horsepower, and of course, we're going to recommend 60 hertz, but we've got the drive set up so that if someone else has already put in one of these 80 hertz drives, they can take the other competitor's drive out, put our drive in, and still leave that 80 hertz pump and motor in the well. We won't make them take that out of the well. So you can set it for 80 hertz. We're always going to recommend 60 hertz. And of course, part of the reason for that is wear and tear on both the motor and the liquid end. They're designed for 3450 RPMs. You are taking them up to 4800 RPMs. That obviously is going to shorten the life. So we prefer that you not do that, but we're not going to tell you you can't do it. Now, again, if you're going to do submersible or if you're going to do 80 hertz, it has to be submersibles only. You cannot do 80 hertz with above ground motors. They can't handle it the same way submersible motors can. As I said, there are some differences there. We're always going to recommend 60 hertz. Now, I'm really excited to show you this because you've really only got 3 different drives. And if you wanted to, you only needed to buy the PID 50. It will run everything. But you can get a PID 10. Now, notice it says maximum horsepower is 1. And then it goes over on the other side there, and you see where it says output amps. I've always tried to train everybody when I talk to people. You always size a drive based on amps. You do not size a drive based on horsepower. Now, that being said, you'll notice the PID 20 is designed around a 2 horsepower, both single and 3-phase. And you'll notice also that it is designed around 8.5 if it's 3-phase. It's designed around 8.5 max load amps output. This is really, really important because this is the DSS4 HG3T. And you're going to notice that whether you're using the DSS3 or the DSS4, it is a 2 horsepower pump. It is 230 volts, and you're going to notice that the 3-phase, you'll notice that the service factor amps at 230 volts, even for the DSS3, is 9.2. If you look at the DSS4, it's 11. So remember, it says here 2 horsepower, and that's a 2 horsepower pump. At least that's what we're calling it. And of course, it's only got 8.5 max load amps, and you're at 9.2. Probably isn't going to work. Okay, it definitely isn't going to work. We've had a few people try it, and we know it's not going to work. So we're just telling you to be very, very careful. Size the drive towards the max load amps. This pump that we're looking at here, the DSS3 and the DSS4, has a 1.5 service factor. So, of course, you multiply 1.5 times 2, you're going to get 3. And so that's really a 3 horsepower pump. We're just calling it 2 horsepower. And yes, it can mess up a drive. And yes, we have had people try to put a 2 horsepower drive on this 2 horsepower pump. And no, it doesn't work. You've got to make sure that you're using the right drive. In this case, you would use the PID 50, which, as you can see, 3-phase goes up to 18 amps. And so it would work very well with this particular pump. So DSS3, DSS4, doesn't matter which one you pick, you got to use that PID 50. All right, now features and benefits here. First thing we're going to mention here is the fact that you've got keyhole mounting system. Okay, when you look at the keyhole mounting system, basically what that is, that's where you're going to attach it to the wall. Now, I'm going to tell you that the drive doesn't weigh a whole lot, but I'm also going to tell you if it was me and I just paid $1,500, $2,000 for a drive, I'm going to put it in a stud. I want to make sure that it's going to stay on the wall. I'm not going to use one of those devices that I can put in the wall and say, there, now it's going to hang onto this drywall. No, not me. Not going to do that. Put it in a stud. If you put it in a stud, you know it's safe. You know it's not going to go anyplace. all right? It does have an intelligent variable speed fan. It only operates, and this is what makes it intelligent, is it only operates when it's necessary. There's a heat sink in the drive, and if it starts to get warm, it turns the fan on, which means depending on where you live, you may never hear that fan, okay? It may never, ever come on. Of course, it's going to conserve energy, and it means you minimize your maintenance a little bit. The only time I know for a fact that you will hear that fan, though, is if you wind up with a low voltage fault, because low voltage will turn the drive off, and once the drive gets turned off, you wind up with a low voltage fault, and you wind up not having any voltage. So it says, hey, we need to get rid of the energy that's on the capacitor pack. So when the voltage goes down, the fan turns on, it pulls all the energy off because the pump has now been turned off. Removable terminal blocks, you can see the arrow is pointing to the output one, which is 3. If you look over on the left-hand side, you'll see there's an input one that's going to be 2. And so, of course, what that does, that makes it very, very easy to wire up this drive. Now, I'm going to admit something that I hate to admit because I tell you all the time, make sure not to do it. But the other day I was wiring up a drive. We were doing a demo at one of the locations I was at. So I was wiring up the drive for the salesman so we could put it all in there. And sure enough, I pulled the removable terminal block out, wired it to the wires, and then went to hook it back in and thought, oh, I didn't go through that hole. And I'll tell you a little secret. It's really hard to get that square peg through that round hole. So pull those wires up through there first, because otherwise you have to do like I did, which is unscrew all the wires, pull them all back out, pull them back up through, and then put them back on. It's like, yeah, you could have saved yourself that trouble if you just done it right in the first place. So make sure you pull those wires up through that hole before you go ahead and attach them to that removable terminal block. All right? There is an SD card slot. Now, which is really cool about this is if we make changes here, we put them on our website, and then all you have to do is go to the website, download them onto an SD card, bring them over here, put the SD card into the SD card slot, and then go to the software and say, hey, I want you to upload this newest thing, okay? And now you've got a new drive, and you didn't have to pay for anything because it's right there, okay? Yes, I will admit we've had to use it in the past. When we very, very first came out with the drive, we had a little bit of a problem with something that didn't get programmed quite right. So we put it on the SD card slot and said, here, go plug it in. People went and plugged it in and everything was fine. It fixed itself. So that's what that SD card slot is for. Updates that gives you a brand new drive without having to pay for anything. All right. You'll notice there are 3 little mounting holes in the bottom there. The one in the middle was added, and the reason it was added is because we found out people wanted to put this on a round post. And it's really hard when those 2 are on the side to try and get this thing in a vertical position if you want to mount it up both top and bottom. So you need to keep it vertical. You don't want it at an angle. So we punched that hole in the middle there, so now you can do it properly. All right. You'll notice also there's a 1/2-inch conduit knocked out. That 1/2-inch conduit knockout is for your transducer wires. If you look carefully, there are 3 other 1/2-inch conduit knockouts there. They're not knocked out. You could have 2 inputs and an output there, and so that's why those are there, just in case you do use those inputs and output. You can go ahead and knock those out and have some place to put them. You don't use them, you don't need to knock it out, obviously. You'll also notice there are 2 3/4-inch knockouts that also can be extended to 1.25" if you need them to. That's, again, up to you depending on the size of your wire and everything. Spacious wiring area, easy to wire. You'll notice there are 2 programmable inputs. Again, as I mentioned in the beginning, there are so many things you can do. This is plug and play. But if you don't want to plug and play, lots of neat things you can do. We'll talk more about those inputs and outputs as we go into our presentation here. A robust EMI RFI filter. EMI means electromagnetic interference. RFI means radio frequency interference. Electromagnetic interference means you can set this drive, turn it on, and when you turn it on, it's not going to make the garage door go up or anything silly like that. Also, you can take an AM radio, put it within about a foot of the drive, and it should work just fine. By the way, if you are getting some crackling on your AM radio, it probably means you're not grounded properly, but the drive will tell you that too. And then we're going to talk about this keypad here. So when you look at the keypad, yes, it does have a backlit LCD display on there, so it's very easy to tell what's going on. There are 3 blue buttons, and the one in the middle there says PSI preset. That is directly connected to the internal set point, and the internal set point is the point at which you always want the drive to run at. So one of the ways that you can change that internal set point, and there are several, one of them is right here by pushing that PSI preset button. There's also a blue button called pump out. Remember, you're putting single phase in, and if you want to, you can run a 3-phase motor. Now, it's really, really difficult to turn that 3-phase motor on if you don't have 3-phase power available to you. And of course, when you're cleaning out your well, you don't want this thing to stop. You want it to run. So you're going to worry about pressure and everything. It's not going to stop if you push the pump out. Pump out overrides all of your pressure, and now it's just going to run this thing. So you decide how you want to run it. There's also a fault log there. It stores the last 15 faults. Now, of course, we're going to assume that you're going to put the time date stamp in properly. Again, we'll talk about how that all takes place. And if you do that, it will time date stamp each one of those faults, so that way you know exactly when it happened. Now, there's also a password button here, and I do want to point out that the blue buttons do not work unless you put the password in. So the password lockout, it says keypad lockout. You use it to lock the keypad, or you use it to unlock the keypad. Now, if you, it isn't, I'm not going to be able to show it on this one, but if you look in the upper left-hand corner, when we look at an actual screen, you're going to notice that there is a little skeleton key up in the corner, and the skeleton key means that you're locked out. When you put the password in, the skeleton key goes away, and that means now you can go ahead and play with the blue buttons. We do have LED status indicator lights, all right? Now, they have nothing to do with faults, except that the red one's going to come on when you have a fault. When there's a warning, the yellow one will come on, and if everything's running just fine, you got power to the drive, the green one will be on that says okay. That's the only time you're going to see those LED lights, and you don't have to count them for fault information and like that, because we're just going to tell you right on the screen what's going on. There is also an auto start. Now you'll notice it says auto start also has auto line fill functionality with it, and we'll explain what that is. There's also those little rectangular lights above status, stop, and auto start. They'll be on too, letting you know where you are. Okay? Now, the basic product that you're going to get here, you're going to get the variable frequency drive. We're going to give you a 100-pound transducer. That transducer comes with 10 feet of cable. Now, I'm going to tell you right up front that if you're further than 10 feet away, buy another cable. Don't use the 10-foot cable. Don't try and splice it. Make sure you're using the correct size cable. If you've got, say, for example, you've got you're 20 feet away from the drive with your transducer, buy a 50-foot and cut it down. Now, don't cut it too short, but cut it so you don't need that extra 30 feet. You don't want to wind it up and save it. Just cut it and get rid of it. But you just want to make sure that you're not splicing the cable, because that's bad. It's very difficult to get that spliced. Remember, your output on this transducer is only 4 to 20 milliamp, and that's a very little bit. So if it's not done correctly, if you're not splicing it exactly correct, you're going to have a problem. So we just recommend you don't splice at all. We're going to give you a quick start guide. It will help you set this drive up. Remember, it is plug and play, so it's really simple to get it started. We'll show you that. There'll be an owner's manual just in case you need it for anything. Now, the transducer, when you look at this transducer, I'm going to point out a section of it here. It is rated at 100 pounds. Now, the drive itself can accept up to a 300-pound transducer, but the problem is you're changing the meaning of 4 to 20 milliamps if you change out the transducer. So unless you've got a job where you require more pressure, a 100-pound transducer is sufficient. All right. Right in that area there where you see the red square on the transducer, there is a plug in there. That plug prevents the water from actually touching the diaphragm. And what that does is that protects the diaphragm. So if you've got a bad water application, this will help to prevent that bad water from corroding or having problems with the diaphragm and so forth. All right. It is 8 to 24 volt input with 4 to 20 milliamp output. What that simply means is this: 4 milliamps is going to be zero pressure. 20 milliamps is going to be your max pressure, which, if you're using the transducer we give you, is 100 pounds. If you divide, there's actually 17, because these are inclusive numbers. So if you divide that 100 pounds by the 17, you're going to find about 6 pounds per milliamp. And this is why you want to make sure that if you want to change that transducer and put a heavier duty transducer in there, you can do it, but make sure that you go in and change your sensor value too then, because the bottom line is a 300-pound transducer is actually recording 18 psi per milliamp. So that would really throw off your pressure readings and cause you lots of anxiety. So 4 milliamps equals 0, 20 milliamps equals 100. That's 6 psi, 5.88, 6 psi. Okay? So when it comes to sizing a drive, you'll notice it first says size per horsepower and verify service factor amps. Remember what I said, size per service factor amps. Don't get excited about horsepower. Horsepower isn't really important. What's important is those service factor amps. If you can cover the service factor amps, you're going to be just fine. Okay? The max load or service factor amps are going to be listed in the owner's manual. So if we look here, this is the PN793, and we're going to tell you, here's your motor type 2-wire, okay? Now you'll notice there's some motors that have a -01 after them and some that don't. The difference is the -01 is a new motor. In what's really new about it is the way that we've redesigned the slots in the motor. That's what you're looking at there. Okay, the question just came up, will the transducer work with air pressure or just water? And the answer is going to be water. So that's, it has to be liquid, something pushing against it, okay? So the difference in those motors there, and of course you'll notice it does make a difference in your amp reading too. And that's always very important to note. So you're going to notice that the service factor amps are a little bit different. For example, we've got the 1.5 2-wire motor there. If it's got the -01, the service factor amps are 10.4. If it doesn't have the -01, the service factor amps are 11. And so that does make a difference. It really does make a difference. And you need to understand that. So make sure you're putting the right ones in there. Now, 3-wire motors. Remember, if you're doing 3-wire motors, you want to use CSCR single phase. Okay, and that's what that blue line there represents, is it's got the CSCR. Remember, you do have CSIR, and of course, you don't want to use that max load amps there. The reason you don't want to use those max load amps is because they're going to be higher than CSCR because you turn off your start windings. With your CSCR, you're using your start winding all the time, and that's why you're running lower amperage through there. So make sure you're doing that. Now, of course, this is going to be, as I mentioned, in your owner's manual, and you can take a look in there, and you can see we give you all that information. Now, it's also going to be listed in the Quick Start Guide, so you can find it there. And of course, you can find it in the PN 793 also, okay? Remember, you always use the service factor amps for Capstar Cap Run, the yellow wire, okay? Capstar Cap Run, you're sending electricity down on black, you're sending it down on red, and you're bringing it up on yellow. And so your yellow wire is going to have your max load amps in there all the time. Now, this is out of the PN 793, and when we look here, there's your CSIR, here's your CSCR. So what we're going to do next here is we're going to look at max load or service factor amps. You'll notice they're over there on the right-hand side of the page. And there's your amps, and we're going to look at a P43B0010A2 because 1 horse is the largest that you can go with the CSCR control box. And so you'll notice there the max load amps are 9.7. Take the exact same motor, P43B0010A2, in your CSCR, and now your max load amps are only 7.2. So you can see there really is a difference. And if you look at the kilowatt difference is almost a little over 140. That's going to make a little difference too. The main thing I want you to understand here is amps are heat. So by reducing the heat, you extend the life of the motor. And that's why I always recommend, no matter what size motor you've got, to always use a Capstar Cap Run control box. We do make Capstar induction run control boxes simply because of the fact that, yes, they do work and you've been taught for years that you can use them. So if you really wanna, I can't stop you, but I'm strongly going to encourage you to always use Capstar Cap Run control boxes. Okay? What makes the difference between the amps? It's going to be that running capacitor. The running capacitor makes the difference here. And because there is a running capacitor, the running capacitor is going to be hooked up to the starting coil. And because it's hooked up to the starting coil, it means that you're sharing or spreading those amps out. You're not putting all that amps on one wire. And so that's why that's important. All right? That's your Capstar Cap Run. Now, here we are again, and just because I'm not tired of it here, here's the same motor. Now, notice this particular page in the book has all 3 colored wires, yellow, black, and red. And again, you're going to notice on all the Capstar induction run, red is always 0 because you're turning off that starting capacitor. On the Capstar Cap Run, while you turn off the starting capacitor, you still use the running capacitor. And so because you're using the running capacitor, you are going to be able to get a lower amperage reading because you're spreading those amps out. Now, again, the other thing that's really important to note there is if you add you add black and red together, they don't equal yellow. And that's something that usually people are going, well, how come it's not equal? And the answer is because the amperage going down that red wire has been boosted by a starting capacitor. So you're not putting all that amperage in there. It's just a boost, so it goes away. Your real amperage is going to be the subtraction of yellow and black, which is in this case 0.9 amps. So you've got 0.9 amps going into that red, but you've got 3.3 going down because you're using a running capacitor to boost that 0.9 amps up. All right? If you look at your 2-wire, we've got the same thing there. Your total amperage is going to be, 14.3. Your running amps, your max load amps are 12.2. And again, that's because of what you're putting into the running capacitor and getting out of it. So lots of benefits to using that Capstar Cap Run control box. Above ground motors have other terminologies such as max load amps, and these are for your smaller motors. I'm going to call them A.O. Smith, but the name has been changed to Regal, so you will be seeing that in the field shortly. Regal purchased A.O. Smith a good 1.5 years ago, and they're just getting around to changing the name. And they do use that term, max load amps. Baldor motors, which are 3 and 5 horsepower above ground motors, use the term full load amps. And of course, full load amps relate to the nameplate horsepower. All right, it doesn't take service factor into consideration. Now, the PID will run other 3-wire, 3-phase motors of the same horsepower. In other words, we didn't set the drive to equal just our own service factor amps. We went out, we looked at everybody's service factor amps, and we said, okay, who's got the most? That's the one we want to use. And so any of the 3-phase motors out there, whoever had the most service factor amps, we've programmed the drive so that it could run that motor too. You still have to set it for the proper service factor amps. Now, this is, again, back to our screen here. The point we want to make, PID 20 has 13.5. Remember, our motor doesn't have 13.5. It's got 12.6. So this is designed around, I believe it's the Franklin motor that has that. So we're in here in the Franklin book, and we're looking at the service factor load, and we come down to the, let's see, there's 4-inch 3-wire. Okay. Now, again, you're going to notice that's your cap start, cap run. Can't use that. You've got to use the next one down, which is cap start cap run, not cap start induction run. Okay. So you want to use the one down below, and if you use the one down below, there's one other thing I want to point out here. Remember, your half through 1 horsepower can be run as cap start induction run or cap start cap run. Now, again, when you go to cap start cap run, it's only 230 volts, so you drop that 115 out, okay? But you'll also notice that they're giving you 2 categories there, 4-inch 3-wire with cap start cap run control box, and the next one down below says 4-inch 3-wire. And you'll notice it goes, the first one that says cap start cap run goes half through 1 horsepower. The second category goes 1 through 5 horsepower. Now, the reason that Franklin is doing this is because you'll notice that when you're using the second one, it's with a 1.5 horse control box. So you're running a 1 horsepower motor with a 1.5 horse control box. You'll notice with the 1 horsepower control box, your max load amps are 7.1. With the 1.5 horse control box, your max load amps are 8. And so that's going to take a toll on the motor. You need to understand that. And you're looking at that yellow wire, which is your max load amps. Doesn't matter whether you're looking at this A manual or whether you're looking at our manual, you want that yellow wire, which is max load amps. Your 2 horse there are 13.2, and that's why we set it for 13.5. So we can cover even the Franklin motor. All right? Now, the next thing we're going to look at here, quick installation. There are no special tools required. What that simply means is that you need a standard screwdriver, a Phillips screwdriver, and of course something to put that top screw in. When I mounted it on the wall, I used my Makita to do that. So you might want something like that. But you just need something to get that top screw in. All right? It accepts 190 to 265 volt. I was down in Texas one time, and somebody down there said to me, oh, we've got the worst electric down here. That's why we don't like using drives. And I says, oh, really? Well, how bad is your electric down here? And he says, oh, it's 230 volt. I said, no, that's normal. What is it? What's the worst? Oh, well, 190. We go down to 190 volts all the time. I says, really? I said, because you know what? This drive works at 190. And he says, you tricked me. Well, I didn't really trick him. I was just stating a fact. Now, tank recommendations, 20% of the rated flow of the pump or a minimum of 5 gallons. Now, 20% would mean that if I was running a 20-gallon minute pump, that would be a 4-gallon tank, so I'd want this minimum tank. Now, if I'm running a 50-gallon minute pump, that's going to be a 10-gallon tank, which means I'll probably wind up using a 19. Let's talk about your wires here. You always want to hook up the output first. Safety factor, okay? Always hook up your output first. So when you're hooking up your output first, right there is your removable terminal block. It will hold up the number 6 gauge wire, Now remember, number 6 gauge wire is really kind of hard to move around, so you may want to leave it in there for 6 gauge wire. But for some of the smaller stuff, you can take it out, okay? No special tools. You just have to have a standard screwdriver small enough to fit in that hole where the screw is, okay? If you're using a 3-phase motor, our 3-phase motors have red, black, and yellow as their wire colors. And I'm going to tell you, when I first saw that, I just kind of had a cow, because I was a little upset about that. I thought, why are you using single-phase colors? How is anybody supposed to know if you've got a single-phase or a 3-phase motor down there? And then I came to my senses and realized all you got to do is put an ohm meter on there and ohm it out. If red and yellow are the same as black and yellow, you got a 3-phase motor, because normally red and yellow would be higher than black and yellow. That's all you have to do, all right? If you hook them up, and the reason why they color-coded them the way they did, if you hook them up the way they're color-coded, you'll never have to worry about this motor running backwards. It will always run in the correct direction, and that's why they did it that way, all right? If you're doing single phase out 3-wire, same thing, red, yellow, black. Now, of course, remember, the drive knows you're doing single phase, so it's going to change the amperage coming out. On 3-phase, red, yellow, and black are each going to get the same amps. On single phase, red and black get different amperage than yellow. And so you got to understand that, all right? If you're going to do 2-wire, this is where it gets a little different, because with 2-wire, you're only going to use yellow and black. Even though the 2 wires might be black and black, or the 2 wires might be red and black, you're going to use yellow and black. The red wire is equivalent on single phase. The red wire is equivalent to that starting capacitor, running capacitor. It's in the cap start, cap run control box. And on a 2-wire motor, we don't have a running capacitor, so we don't even use it. So if you don't hook up to yellow and black, it's gonna fault out on you. All right. And then most importantly, don't forget to connect the ground wire. A drive must be grounded all the way back to the main breaker. That's where you want to ground it. You don't want to ground it anyplace else. You want to ground it all the way back to the main breaker. So bring it in here and connect it to that grounding lug there. When you're doing your transducer, AI plus is going to be red, AI minus is going to be black. Those are spring loaded, so all you can do, you can just push them up with your fingertip if you want. A screwdriver gives you a little more room to see with, but you just push them up, stick the wire in. Now, the other thing I'm going to mention to you is make sure that you strip enough wire off so that when you push that wire up in there, you're not on the coating of the wire. Because obviously, if you're on the coating of the wire, that coating is an insulator, and you're not going to sense anything. So you make sure that that wire is stripped back far enough. When you put it up in there, you're on the stripped wire. The other thing that's very important is there is a 3rd wire in there. It is a shield cable. And you want to hook that up to the shield cable lug. Don't hook it up to the ground wire. Hook it up to the shield cable lug. And then on your input, you're going to have your L1 and L2 connections. Remember, you can pull that out and hook them up too. All right. Pull your wires through the round thing first. All right. And of course, don't forget to connect the ground. Your ground will go all the way through the box, then back to your disconnect switch, and then from your disconnect switch back to the main breaker box. And yes, you really, really should have, for safety's sake, a disconnect switch between the VFD and the main breaker box. There really should be a disconnect switch there. So take it all the way back to the main breaker box, and your grounding shouldn't have any problems at all. Now, startup. Startup looks like this. You're going to apply the 230 volt, all right? Press enter. Then it's going to ask you a question. The question is, are you running a single-phase motor or are you running a 3-phase motor? It's that simple. You pick which motor you're running, all right? Remember, it's always going to be 230 volt single-phase in, but you can choose your output, and this is where you're going to choose your output electric. Do you want a single phase or 3-phase? You'll notice if you look over at the picture of the screen there, the screen says 3-phase. If you were to hit enter right now, it would mean that you would have a 3-phase motor. So whichever one you pick, you press enter, and that's the one that it chooses. If you pick single phase, it's going to ask you another question, and the question is, are you running a 2-wire motor or are you running a 3-wire motor? If you have picked 3-phase, the second question is going to be, are you running a submersible or are you running an above ground motor? Pick the appropriate answer and then press enter. Once you've pressed enter, now it's going to ask you, what are your service factor amps? Put them in and press enter. Then it's going to ask you to set the time. Now, I know a few people who want to speed the process up, so they don't want to take the time to set the time. If you don't set the time, if you just hit enter here, it accepts it at the default time, which is midnight. Okay? So you can just press enter and not put a time in. Of course, if you do that, you're not going to have the accurate time. It's going to ask you to set the date. If you don't take the time to set the date, if you just press enter, it'll set a date, January 1st of 2009. We're a little ways away from that. That's going to panic your customer when they see that on the default log. So it's kind of important that you do set that time and date. All right? When you set that date and you press enter, you're done. Now I'm going to tell you right up front, if this process 5 steps, if it's not done, the drive will not start. You must at least press enter after each one of those. If you didn't enter service factor amps, you just hit enter, it's going to stay at 0 and it'll say, fine, I'm going to run this pump at 0 amps. Now you know how much work you're going to get at 0 amps, don't you? None. So pump out. Remember what I said, pump out is one of those blue buttons, all right? It has a very, very important function. So it starts out with the question, is a valve open? The answer is no. You have to do one of 2 things, or maybe you have to do 2 of 2 things. You have to open a valve and then change the no to a yes. If you don't open the valve and you say yes, you're accepting responsibility for burning the motor up, because now you're going to deadhead the pump. If you open the valve and then say yes, it will turn on. When it turns on, you're going to notice that it's going to go to 45 hertz. Now, there's a reason why we pick 45 hertz, because unless you have extremely oversized the pump in the well, 45 hertz should not cause upthrust on the motor, and you shouldn't have a problem. You can change it. All you have to do is push enter. A black box appears around the 5. You can go up or down from there. But remember, you're accepting responsibility for it. You'll notice there we say, do not walk away. You have to press stop. If you don't press stop, the pump just keeps running. So it's like a HOA switch on a sewage system, if any of you guys know what that's like. Now, auto start, you'll notice when you push the button, the on light is going to be on. There's power to the system. And when you push the auto start button, that's going to turn that light on. Now, the first thing that's going to happen, it's going to go up to 45 hertz and then slowly build. All right? It'll tell you what the amps is. It'll tell you you're running a fixed pressure. And you'll notice the key's not on this one. So we're doing original setup here. Okay? It indicates auto line fill first. Where it says running fixed pressure, it's going to say auto line fill first. Now that may disappear very quickly. You may just see it flash, and if you're not watching, you may not even see it at all. Because if your line already has 10 psi in it, it just goes right to 60 psi then. Okay? But if you're filling the line up for the very, very, very first time, and you've got a long line to fill up, it will say auto line fill. It will say 45 hertz, and when your pressure gets to 10 psi, then it will go ahead and kick in and start running at max, okay? Otherwise, it's going to run at 45 hertz, slowly build up to 55, trying to get to that 10 psi. Once 10 psi is detected, yes, now it goes into PID mode, and that does not mean Pentax IntelliDrive. It runs for a total of 3 minutes. If it doesn't hit that 10 psi in 3 minutes, it will indeed turn off. All you do at this point, turn it back on. That's all you have to do. Now, sleep. With sleep, what we do, and the main thing I'm showing you here, is we boost the pressure 3 psi, and when the pump goes to sleep, it says sleeping. So all it means is we've turned it off because we don't need it right now. So you're at 0 hertz and 0 amps, okay? Your sleeping mode looks like this, okay? Number one is a boost delay. Boost delay means that we're running at the same pressure and the same hertz for 1 minute. So let's see if we need to go to sleep. How do we do that? We boost the pressure. We boosted 3 psi. You can adjust it, but we boosted 3 psi. Now, you'll notice number 3. Number 3 is a little confusing because it says wake delay. And basically what it really means is this. If the drive drops that 3 psi right away, it just continues to run in PID mode, okay? If it goes up that 3 psi and stays there, now you're going to go to sleep. You must drop. In other words, what it's going to do, it's going to say, I'm at 63 psi, I'm going to wait 15 seconds. You decide, do I go to sleep or do I continue running? And that's what that number 3 is. Again, you can see it's adjustable, all right? Number 6 says, okay, we've gone to sleep, and now we've got to drop all the way down to 5 psi below our set point before we're going to turn back on, okay? And that's our wake-up deviation. So you've got a 9-pound differential in that system, which is good because it gives you a chance to move the water through the tank. So let's take a poll. What is the importance of the overpressure feature? Is it a safety measure? Is it the initial setup pressure? Is it monitoring sleep? Or is it exceeding the set point pressure? The person that picked it's a safety measure, that's correct. This is a safety measure. And so we want you to understand that in PID mode, all the overpressure does is it watches to see what's taking place. If I go more than 20 pounds over the set point pressure, it's going to shut the drive down. I will tell you this, you need to change that if you change your set point pressure. I had somebody call me up one time and they say, I don't get it. I set the set point pressure at 90 and it keeps going off at 80. It won't get to 90. What's going on? And so I said to the guy, are you at the drive now? He said, yes. I said, okay, I want you to put the password in and then pick main menu. So he did. When he was done, he told me he was there. And I said, all right, now I want you to scroll down to where it says overpressure. And so he scrolls down to where the black box is behind overpressure. I said, okay, now hit enter. So he hits enter. I said, what does it say? He says 80. I said, all right, change that to 97. So he changed it to 97. I said, all right, now hit enter. So he hits enter. I said, all right, now go ahead and hit your status button and turn the pump back on. And it went right to 90 PSI. So the bottom line is that he hadn't changed his overpressure, but he was setting the pressure set point higher than what overpressure was. Going to hit overpressure, it's going to trip. Now, the reason I said 97 is because, remember, that's the highest pressure that I can have with this drive. I can't go over that. And the reason I can't go over it is because of the fact that you've got 100 pounds max on your pressure transducer. So if you hit 3 PSI, in order to hit that 3 PSI, 97 has to be your maximum pressure you can set it for. And once the drive goes into that, it says, okay, do I need to go to sleep? No, it won't overpressure. It can't overpressure. So 97 is the max unless you put on a different transducer. Then you got to change that. We remove the Temp Performance mode as far as what you're going to see on the screen. It is still there, but it's not displayed. What you're going to see now, there's that little yellow warning light down there, and the little yellow warning light will come on when it goes into Temp Performance mode. For those of you that don't know what Temp Performance mode is, it means it's getting hot in here. I've turned the fan on. I've sped it up as fast as I can. I still can't get the heat to go down, so now I'm going to remove the heat from another way. And of course, the other way is, let's start slowing the amperage down, because amps are heat. And so it says, let's slow the amperage down so we can bring the heat down. It will run at Temp Performance mode for 3 hours before it trips on over temperature. Fault conditions, You're going to notice the first two there are under voltage and over voltage. If you look on the screen, it says fault, and then right below it, it tells you what the fault is, and right below that, it says restart pending. If you're getting a voltage fault, do not hit reset, because the bottom line is, as soon as you turn it back on, unless it's already fixed itself, it's just going to fault out again. So wait for the voltage to come back up. When the voltage comes back up, it will turn back on automatically. No, it won't forget anything. It'll remember everything you told it, so you don't have to worry about that, okay? But those are auto restart. Auto restart means the drive monitors the condition and attempts to restart when the fault conditions are removed. The next one that's there is overcurrent. And you'll notice overcurrent can be a problem of short circuit, damaged insulation, and yes, I've seen that one before. It can be pump loading issues, or it could be sensing on all phases. And so that's going to cause a problem, and it's going to be called overcurrent. Now, the next one we're going to talk about here, when you get there's two types of faults. We call them soft fault and a hard fault. The soft fault is the drive is going to attempt to restart itself. A hard fault means the drive is stopped. When the drive is stopped, somebody must push the fault reset button and then hit the start button again. Of course, you're going to have to fix the fault before you do that, because if you don't know what the fault is, if you didn't find the fault and fix it, it's just going to jam up again and it's going to fault again. Motor cannot start. It used to be called foreign object jam. It's called motor cannot start. It means that there's something preventing the drive from getting to 30 amps. Now, I want you to know that the drive is intelligent enough that it will ratchet back and forth 5 times for 5 seconds each to see if it can unloosen whatever it is that's jamming it. If it can't, then it will fault and be drive stopped. If you see a cannot start motor fault, you need to pull the pump. You know that something is jamming up that motor and it can't start. If it is a ground fault, you must find the ground. Someplace between the pump and the motor, the pump and the drive, there is a ground, and it's picking up that ground. So you've got to fix that wire. You maybe nicked a wire putting it down, okay? Dry run fault means that the well is run out of water. When the well runs out of water, it says, okay, I've dropped pressure. I was running along in 60 psi, and all of a sudden, boom, I'm down below 10 psi. I'm going to wait 15 seconds just to see, and if it doesn't fix itself, then I'm going to trip on dry run fault. Then it says, okay, now that I've tripped on dry run fault, I'm going to wait 10 minutes to see if this well will recover enough so that I can put the motor to sleep. Okay? And then in 10 minutes it turns on. If it can't put the pump to sleep, it'll fault again. Now, if it faults a third time, then it goes into drive stopped. But the first 2 times that it faults, it'll say restart pending. You can wait 10 minutes, or you can push the reset button and hope that you got enough water to get the thing to go to sleep. All of that is adjustable. The 10 psi is adjustable. The 15 seconds is adjustable. The 10-minute wait is adjustable. The number of times I restart, that's all adjustable. Now, the next one we're going to talk about here is excessive runtime fault. What that simply means is that the drive has not gone to sleep in 24 hours. If the pump isn't going to sleep in 24 hours, it could mean a broken pipe. It could mean something else is going on. You're always using water, and you need to know that. So that's all it's going to do. It's set for 1 hour, but you can set it for anything you want to. Open transducer or shorted transducer. Again, these are auto restart. These are 2, however, that I'm not necessarily going to wait for. It's not like the voltage ones, okay? They will restart if the problem fixes itself. But if you've got an open transducer, there's a possibility it's not going to fix itself. So you need to find that out. Or if you've got a shorted transducer, you need to find that out so you can fix it. Our next one, over temperature fault, obviously, if the temperature goes too high and remains there for more than 3 hours, the drive is going to shut down. Okay. Now the good news is that over temperature is actually 122 degrees. So it used to be 104. So we've raised it quite a bit. It's 50 degrees centigrade. So that's 122 degrees Fahrenheit. Low amps fault, it used to be called the open lead fault. What it basically means is we're not picking up anything on the common, so we're putting electricity down, we're not bringing electricity back, or our three-phase isn't connected properly. It will try to reset after 15 minutes, and again, it could fault out again, okay? External fault, this is where I'm going to program one of those digital inputs. And when I program that digital input for external fault, what I'm saying is, well, let's say, for example, I want to use a moisture sensor. So I put the moisture sensor on the floor. I connect it to input 1. Don't forget, you've got to have a 115 plug out to plug the moisture sensor in, so that way you can send a signal. When moisture hits the 2 contacts down there, it sends a signal up to the drive and says, hey, there's water down here on the floor. You better turn the pump off. So I want you also to understand that while the moisture sensor is an automatic reset, this is not. Somebody's got to come down here and push the fault reset button and then push the start button again. Internal and hardware fault are the two you don't want to see, because those are catastrophic failures with the drive itself. Everything else we've talked about has been a system problem. And this is telling you, okay, fix the system problem. This one is saying, hey, this is a drive problem. Now, when your customer calls you and says the drive's not working, we don't have any water, ask them what the screen says. If it says internal or hardware, tell them to turn the power off to the drive. You'll know they did that. Don't forget the fan's going to come on, so you'll hear that fan come on. And then have them go ahead and wait 5 minutes. Now, you can stay on the phone with them or you can call them back. It's up to you. Then what you do is you go ahead and you turn the drive back on. If it hits this again, tell them to turn it off. Wait 5 minutes. Call them back. Turn the drive back on. 3 times. If you get 3 faults, they all are the same and they're 5 minutes apart, we know you did your job. That is a warranty. Call them up and say, hey, I'm going to bring a new drive over, and you know you've got to take another drive. All right? That's what's nice about internal or hardware fault, is it's letting you know in advance, take a drive with you because this drive is no good. The last one there is system not grounded fault. If you do not connect your ground wire all the way back to the main breaker box, or if you try to put more than one ground wire in, you're going to have problems. And the system is going to say, system not grounded. It will turn the pump off. You can go out there and disable that, but it will only be disabled for 72 hours and it's going to turn back on. So the bottom line is, when it says system not grounded, if it's 11 o'clock at night and you just want to go home, disable it. But remember, in 3 days, you got to get out there sometime in the next 3 days to fix it. Otherwise, you're stuck. So let's take another poll here. This poll says, what is the importance of grounding? Unstable pressure reading? Yes. Several open transducer faults? Yes. Drive does not go to sleep? Yes. Pressure relief valve opening up? Yes. EMI interference with electronics? Yes. So the right answer is F, all of the above. Couple things we want to look at. When you go to the main menu, under settings, the first thing you're going to see is time date. So basically what you do is you hit that main menu button and it pulls up settings. Then you hit enter and it pulls up time date. If you want to change it, go ahead. Now notice it says we defaulted it to a 12-hour clock, but if there's anybody out there that's military and you like that 24-hour clock, enter your time, enter your date. Under sleep, if you don't do time date, push the down arrow, it'll come up as sleep. If you push the enter button, then it's going to say boost differential. Now remember, we defaulted it to 3, it can go up to 10. The next one down will say boost delay. Again, if you want to change this, hit the enter button. Remember, we say wait 60 seconds and then boost. You can change that all the way down to 30, all the way up to 300 seconds. Wake up differential, we defaulted it to 5. You can change it from 5 to 15. So if you've got a really large tank here and you want to make sure you're flushing that tank out, you may want to either change the boost differential or change the wake up delay. But remember, whichever you do, your customer is going to notice that pressure differential in there. And then wake up delay, we've set it for 15 seconds. It goes all the way down to 3 or all the way up to 120. It's up to you. Under motor menu, it's going to ask for the phase. And then, of course, remember, which are you picking? And that's going to be based on the phase that you pick. It's going to ask for service factor amps. All right. Remember, your minimum frequency is going to be 30. It can be adjusted up if need be. It cannot be adjusted down. We get asked that question all the time. The answer is no. It was originally designed for submersibles, and 30 is the minimum. Maximum frequency is 60. Remember, when you're doing single phase, that's it. It won't even ask you, do you want to go up? If you pick 3-phase, it will allow you to go up to 80 if you pick submersible. If you didn't pick submersible, it won't let you go up to 80 there either. Under main menu for dry run, remember the number of resets. We say wait 10 minutes. It can go down to 3 or up to 60. Remember, if your customer's in the shower, you put 60 minutes. They're waiting 60 minutes to get water to rinse off with. A number of resets, we set it for 3. The range is 0 to 5. All right. If you set it for 0, remember the drive never attempts to start again. Somebody has to go down and push the reset button. The sensitivity is set for 10 psi. You can change it, 0 to 300. If you set it for 0, it's the same as disabling. You don't want dry run then. Fill time is defaulted to 1 minute. The range is 15 seconds to 10 minutes. And of course, detection time is set at 15 seconds. The range is half a second to 10 minutes. Now, digital inputs, we send them out unused. Remember, there's 2 of them. They're identical. You can put them for external set point. What this means is I want to run a different pressure. Say, for example, I'm running a sprinkler system. And so I want my sprinkler system to run at 70 psi, but I want my regular system, my house system, to run at 60. Remember that when you change the pressure, you are changing the pressure in the whole system. So if you change it up to 70 or you change it down to 45 for your sprinkling system, your whole house is going to be that way until the sprinkling system turns off. You're going to run your timer from your sprinkler system over to one of your digital inputs, and you're going to set that digital input for external set point. All right? Remember, external fault basically says, I want the drive to turn off. So you can take digital input 2, and you can hook up that moisture sensor. You can hook up a float switch on a cistern, so that way when the cistern gets too low, the pump will turn off. Or you can do it the other way. Run enable. Hook up that cistern that says, I don't want this thing to run until there's enough water in there, and so the float has to be on to do that. All right? Now, outputs, there's 3 things you can do with an output. It's going to come unused. That's the first thing you do, is just leave it unused. You can use it for run. Run means that when the drive turns on, I want the output to close and turn something else on. Now it can be hooked up to a light, and so therefore the dry contact closes and sends a signal to that light and turn that light on. It can be hooked up to another pump via a pump start relay. In other words, you cannot run the other pump from the drive, but you can tell the other pump to turn on with the drive. So you put this in run, and then when it closes, it sends a signal to a pump start relay that will close, that turns the electricity onto the other pump. All right? And of course, when the pump stops running, the electricity goes away and the relay opens up. All right? Or you can set it for fault. If you set it for fault, usually this is going to be used with the auto dialer. So I either that or a light. Again, this is another time. One way I want to see the light when the pump is running. The other way says I want to see the light when there's a fault. Okay? So either way. Now, this is the last slide. It's a very important slide because it makes a comparison. So the first item there, NEMA 3R, yes. The display, we give everything in text. Fault indicator, flashing light, text. You look at it, you read it, you see exactly what it says. Number of adjustable parameters. Here you want a high number. 6, 3, we have 34. And that's what I mean by say it's plug and play, or you can do so much more with it. It's totally up to you. Totally up to you. Maximum horsepower is 5 for everybody. Total number of units, here you want a small number. 4, 7, count all the enclosure types, and they have 11. We have 3. So you only have to keep 3 different ones in stock, and then you've got one of each. Ground detection, they don't have it. We do. Programmable inputs and outputs, they don't have them. We do. Thank you for being here.